Adding a 50 amp 3-phase load to an existing 125 amp panel requires careful consideration due to potential overload and voltage drop issues. The existing panel is rated for 125 amps and already has existing loads including two 30 amp 3-phase loads, a 50 amp 3-phase load, and some 20 amp single-phase loads. The 50 amp load runs full-time. Now, adding another 50 amp 3-phase load that will also run full-time presents a challenge, as it will likely exceed the panel's total load capacity. Using number 6 American wire gauge wire for a distance of 80 feet will result in a voltage drop of approximately 4.4%. Let's explore some solutions and considerations. Firstly, consider installing a subpanel with a separate disconnect. This involves installing a 125 amp subpanel next to the existing panel and providing it with its own 125 amp disconnect. Connect the subpanel directly to the switchgear using appropriately sized cables, and then connect the new 50 amp load to this new subpanel. This approach isolates the new load and prevents overloading the existing panel. Secondly, an alternative is to replace the existing panel with a larger one. You could replace the existing 125 amp panel with a larger capacity panel, such as a 200 amp panel. Install the new 50 amp breaker directly into this larger panel. It's essential to ensure that the feeder cables connecting the panel to the switchgear are also appropriately rated for 200 amps to handle the increased capacity. Now, let's address some other important considerations. Firstly, there is voltage drop. The calculated 4.4% voltage drop over the 80 feet of number 6 wire may or may not be acceptable, and this depends on the sensitivity of the new load to voltage fluctuations. If the equipment is sensitive to voltage variations, consider using a larger wire gauge to minimize the voltage drop. For example, you could use number 4 or number 3 American wire gauge wire. Secondly, the short circuit current rating is crucial. Ensure that any new 50 amp breaker installed, whether in the existing panel or a new subpanel, has an appropriate short circuit current rating for the electrical system it's connected to. This rating must be adequate to handle potential fault currents at that location. Thirdly, a permit and inspection are necessary. Any electrical work should be performed by a qualified electrician and must be inspected by the local authority to ensure compliance with all applicable electrical codes and regulations. Code compliance is essential for safety and to avoid potential issues with insurance or future modifications. Let's delve deeper into the voltage drop calculation. A 4.4% voltage drop might seem small, but its impact depends on the voltage tolerance of the equipment being powered. Equipment manufacturers typically specify an acceptable voltage range, often plus or minus 5% or 10% of the nominal voltage. If the voltage at the equipment terminals falls outside this range, it can lead to reduced performance, overheating, or even equipment failure. To accurately assess the voltage drop, you need to consider the following factors. Firstly, the actual load current. The voltage drop calculation is based on the expected current draw of the new 50 amp load. If the actual current is lower, the voltage drop will be proportionally lower as well. Secondly, the wire type and insulation temperature rating. Different wire types such as copper or aluminum have different conductivities. Also, the insulation temperature rating of the wire affects its ampacity, which in turn affects the voltage drop. Thirdly, the power factor of the load. If the load has a low power factor, it will draw more current than a purely resistive load, leading to a higher voltage drop. To mitigate excessive voltage drop, several strategies can be employed. One strategy is to increase the wire size. Using a larger wire gauge reduces the resistance of the conductor, thereby reducing the voltage drop. For example, instead of number 6 wire, consider using number 4 or number 3 wire. Another strategy is to shorten the wire run. If possible, reduce the distance between the panel and the load. A shorter wire run will naturally result in a lower voltage drop. Next, consider using copper conductors. Copper has a higher conductivity than aluminum, so using copper conductors will reduce the voltage drop compared to using aluminum conductors of the same gauge. Now, let's consider the short circuit current rating in more detail. The short circuit current rating (SCCR) of a breaker indicates the maximum fault current that the breaker can safely interrupt without failing. It's crucial to ensure whether the breaker's SCCR is equal to or greater than the available fault current at its location in the electrical system. To determine the available fault current, a short circuit study should be performed. This study takes into account the impedance of the utility transformer, conductors, and other components in the electrical system. The available fault current is typically highest at the service entrance and decreases as you move further downstream in the electrical system. If the available fault current exceeds the breaker's SCCR, the breaker may fail to interrupt the fault, potentially leading to equipment damage, fire, or injury. To increase the SCCR of a circuit, you can use current limiting breakers or fuses. Current limiting devices reduce the magnitude and duration of fault currents, thereby reducing the stress on downstream components. Now let's talk about NEC, National Electrical Code, requirements. The NEC provides detailed requirements for conductor sizing, overcurrent protection, and other aspects of electrical installations. Article 210.19 addresses branch circuit conductor sizing and requires that conductors be sized to carry the non-continuous load plus 125% of the continuous load. A continuous load is defined as a load that operates for 3 hours or more at a time. Article 215.2 addresses feeder conductor sizing and contains similar requirements for feeder conductors. Article 240 provides requirements for overcurrent protection and specifies the maximum size of overcurrent devices for different types of conductors and equipment. Article 250 covers grounding and bonding requirements, which are essential for safety and to minimize the risk of electric shock. When installing a subpanel, several NEC requirements must be followed. Firstly, the subpanel must be properly grounded and bonded to the main panel. Secondly, the neutral and ground conductors must be kept separate in the subpanel. The neutral conductor should only be connected to the neutral bus, and the ground conductor should only be connected to the ground bus. Thirdly, the subpanel must have a main overcurrent protective device, such as a breaker or a fuse. This device protects the subpanel and its branch circuits from overloads and short circuits. Now let's discuss the practical steps involved in installing a subpanel. Firstly, you need to select an appropriate location for the subpanel. The location should be easily accessible and provide sufficient working space. Secondly, mount the subpanel securely to a wall or other suitable structure. Thirdly, run the feeder conductors from the main panel to the subpanel. Ensure that the conductors are properly sized and protected in conduit. Fourthly, connect the feeder conductors to the main lugs in the subpanel. Ensure that the connections are tight and secure. Fifthly, connect the ground and neutral conductors to the appropriate buses in the subpanel. Sixthly, install the branch circuit breakers in the subpanel. Seventhly, label all of the breakers and conductors clearly. Finally, test the installation to ensure that it is working properly. When replacing the existing panel with a larger one, similar steps apply, but there are some additional considerations. Firstly, you need to energize the existing panel completely before starting any work. Secondly, disconnect all of the existing branch circuit conductors from the existing panel. Thirdly, remove the existing panel from the wall. Fourthly, install the new panel in the same location. Fifthly, connect the feeder conductors to the main lugs in the new panel. Sixthly, reconnect all of the branch circuit conductors to the new panel. Seventhly, label all of the breakers and conductors clearly. Finally, test the installation to ensure that it is working properly. Remember to always consult with a qualified electrician and follow all applicable electrical codes and regulations when performing any electrical work. Safety should always be the top priority. When working with electrical systems, always de-energize the circuits before working on them. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician to do the work. They have the knowledge, skills, and experience to perform the work safely and correctly. In summary, adding a 50 amp 3-phase load to an existing 125 amp panel requires careful planning and execution. Consider the load capacity of the existing panel, the voltage drop in the conductors, and the short circuit current rating of the breakers. Explore options such as installing a subpanel or replacing the existing panel with a larger one. Always follow all applicable electrical codes and regulations and consult with a qualified electrician if you have any questions or concerns. By taking these precautions, you can ensure that the electrical installation is safe and reliable. Always prioritize safety and consult with qualified professionals for any electrical work to ensure compliance and proper functionality. Doing so minimizes the risks of electrical hazards and ensures long-term reliability of the electrical system. Understanding the fundamentals of electrical systems and adherence to safety protocols are paramount for any electrical project. In conclusion, there are several aspects to consider when adding a 50-amp 3-phase load to an existing 125-amp panel, including the load capacity, voltage drop, short circuit current rating and national electric code requirements. Remember, safety should always be the top priority.